Okay, so we're in section 3.5 and we're going to learn this very important idea called transformations. We'll find that it's a really quick way to do some graphing, to do some curve fitting, to talk about our functions, to figure out where it starts to increase or decrease or what happens to x-intercepts. Lots and lots of things to see. There's actually two types of transformations, those that impact y values, outputs, and those that impact x values, inputs. So what I'm going to do in this video first is handle the ones about the outputs, take a look at the big three, and then we'll go look at the inputs later and then put it all together as we slowly go through things. Essentially what a transformation is, it's a way to create a new function by manipulating the one that I have. So what we're going to be doing in terms of y is we're going to be shifting it up, we're going to be shifting it down, we're going to be reflecting it through the x-axis. We're going to be making it skinnier, or we're going to be making it flatter, whatever the case might be. We call those vertical stretches or compressions. So those are ways that we can do that. So it's the same function, but manipulated in a new way. What I'm also going to do is I'm going to begin this journey throughout this intro, if you would. I'm going to continue to use the square root of x function. So again, this function starts at 0, 0, 1, 1, 4, 2, and it basically has that shape right there. So what we're going to do is see that shape manipulated. We're going to shift it up and down. We're going to be reflecting it. We're going to be stretching it, all kinds of crazy stuff, and we're obviously going to see how. So the first big type of transformation is to get our graph to vertically shift up or down. What we do is we create a new function, I'll call it y, that takes our function we're talking about, and we're going to add or subtract a k value. And the idea here is that we're hitting all the y values of f of x. So all the outputs of f of x are being impacted by adding or subtracting some value of k. So let's see what happens here. All right. So for again, for our basic function square root of x, my new function here is whatever f of x is plus 3. So this new function is the square root of x plus 3. This new function here would be the square root of x plus 6. This one would be the square root of x minus 4, and this one would be the square root of x minus 8. So there's our new functions composed by the notation that I'm showing us. So f of x again is the square root of x. We're adding 3 to it, we're adding 6 to it, we're subtracting 4, we're subtracting 8. One other word of note, notice that this is not happening underneath the radical, right? This is outside of the radical, so it's not part of the radicand. So let's go to our graphing calculators then, right? What the heck's going on here? So I'm going to go to y equals, oops, better turn it on first. And again, there's our square root of x function, right? And what it looks like pretty much. So let me go ahead let me mess around with my window. I'm going to let the x, y min, let's let that be -8 and 8 respectively, so we can just kind of see a little bit more detail. So there's our square root of x function. So what about the square root of x plus 3? So typing that out, right, we got that one. So when I go graph that, right, what it basically does is takes that graph and it shifts it up. So basically the graph went up 3 units. So what do you think is going to happen when I add 6? Right? Well, it's basically going to be this graph shifted out just 1, 2, 3 times, but 6 times. So let's just do that. As a matter of fact, I'm going to keep the plus 3 there just for comparison. So second square root, we've got x, and we add 6. So when I graph that, there it is. So here's the basic function. Here it is shifted up 3. Here it is shifted up 6. And again, the x coordinates aren't changing. It's all the y coordinates, so it's kind of hard to see, but the y coordinate here is 1, as opposed to up here it's 1, 4. Up here it'd be 1, 7. I think 2, right, when we had 4, this was 2. So if I add 3, it's at 2, 5. If I go to this one, right, it's going to be 8. All right, respectively. So the x values aren't changing, it's the y values that are changing, and we're adding, in this case, 3. So what do you think is going to happen if we subtract 4 and subtract 8? It's going to shift down. So again, as comparison, let's go ahead, let me keep that on, let me keep that on, and we're going to go second square root of x, and I'm going to be subtracting 4. Heck, while we're at it, why don't I go ahead and do the second square root of x, and let's just do the minus 8 one, just so we can see that. Okay, so we have so our basic function is the square root of x. Where we shifted it up 3, we shifted it up 6. Now I shifted it down 4, and I shifted it down 8. So the y value, the x values are staying the same, 0, 1, 4, yada, yada, yada. But it's all the y coordinates along this curve that are being added to or being subtracted, causing the shift up or down. So there you go. So conclusions. So f of x plus k, we go up k units. F of x minus k, we go down k units. Alrighty, and so there you have that. Another way that we can manipulate the graph is to vertically stretch it, alright, or compress it. What I mean by this is we're basically taking a graph and we're making it longer and skinnier, if you would, or we're squashing it in and making it a little flatter. And the way we do that is we basically multiply by some factor of a. Alright, so again, here's my old y values, my outputs, and each y value is getting manipulated by a. It's being multiplied by a, not added, right, or subtracted, but multiplied. So that means we're going to magnify, to get skinnier, we're going to magnify it, or to compress it, we're going to basically multiply it by some fraction. So we're manipulating all the y values, they're being multiplied by some factor of a. So again, my basic function is a square root function. So if I have 2 times f of x, this would be 2 times the square root of x. Here, this would be 4 times the square root of x. This would be 1/3 times the square root of x, and this would be 1/5 times the square root of x. All right, so we're just taking our function and multiplying it by 2, multiplying it by 4, multiplying it by 1/3, and multiplying it by 1/5. So again, let's go to the graphing calculator. I'm going to, let me go ahead and clear that, clear that, clear that, clear that. I think I clear that. And let's go ahead and just put these 4 functions in here. So first, we have 2 square root of x. Okay, so when I go graph it, there's the original one, and here's the other one. Notice it's still going 0, 0, but it's been stretched out vertically. So again, the y value here was 0, it stays at 0. The y value here was 2, it's now at, was 1, doubling it, it's now at 2. At 4, the output was 2, doubling it, it becomes 4. So we have the 0.44. So it's been stretched out. If I did the 4, let me keep the 2 in there. So we got 4 times the square root of x. When I go graph that, right, there's our square root of x. There it is multiplied by 2, and here it is being multiplied by 4. So the graph is being stretched out. Again, the 0 doesn't change, but when x was 1, our output was 1. So if I multiply it by 4, right, the output is now 4. So it's being stretched out. And then last but not least, you can see, right, maybe you can gather, if I'm going to be multiplying it by 1/3, the graph's actually going to get flatter. It's going to be compressed. But let's just go ahead and see that. I'm actually going to just do 1 because this is getting a little lengthy already. We're almost 9 minutes. So how about I put some parentheses in here. We have 1 divided by 3, close parentheses, and then the second square root of x. And then we go ahead and clear that. So when I go graph this, there's the original function, and there it is being compressed by a factor of 1/3. So again, the output at 1 was 1, now it's 1 and 1/3. So there's our vertical compression. So the idea here then is if a is greater than 1, right, we have what's called a vertical stretch, right? If our a is between 0 and 1, we have a compression. Okay, and then we're talking about a of f of x is our new function. So we can stretch the graph out, or we can compress it and compact it in. So those are our 2 big major ones that impact y. There's actually one more, but we're out of time. We're almost 10 minutes. I will cover that in the next video.